So we are going to go over some examples of interval notation and how to go back and forth between set notation, interval notation, and graph systems. So we have this first example that's been completed for us already. We see the set notation with inequality, the interval notation with all parentheses, and then we see the two different graphs of intervals. You don't need to do both. You just pick one example that you like and just go with that. So for the next row here, we're given the interval notation from negative infinity to 0. And we see the graph here. The arrow is going on the negative infinite direction. And then we have an open circle or parentheses at 0. So we want to write this as set notation. So what we will do is we will need to obviously start the set with the curly bracket, and this is set of x, such that we have x values, and those are all less than 0. So we'll say x is less than 0. It's not equal to, it is open 0. That is our set notation. For this next one, we have the set and interval notation. We want to draw the graph of it. So I'm going to go ahead and draw a number line. And I prefer the circle method of graphing. It really doesn't matter what you pick. So we have the interval from 1 to 5, and this is an open interval, meaning 1 and 5 are endpoints, but they are not included. So let's say this is the middle, that's 0. So say this is 1, 2, 3, 4, 5. So that's 5 right there. I'm going to make this a little smaller there. So I'm going to have an open circle, at 1 and at 5. And then I will just connect those because x is everything in between. So that will be my interval graph. Next, we have the set of all real numbers. So that means we're spanning all of the number line. So you can see here that the whole number line is bolded. And so the interval notation for this will always be negative infinity to positive infinity, with open parentheses on either end. In this example, we have the set of x such that x is less than or equal to 5. So if we look at the graph that's already here, we can see that there's a closed point at 5, and then we are highlighting all the values that are less than 5. So on the leftmost side, I'm going to have negative infinity, and then all the way to the right, it's going to end at 5. And it's going to include 5, so I need to use a closed bracket, 5. You see in the next row, this interval is going from 7 to infinity, and it is closed at 7. So that means we need to include 7, and we can see in the graph here, it's closed at 7, and then it's everything greater than that. So our x's are all greater than or equal to 7 in this case. For the next one, it is a completely closed interval, meaning the endpoints are both included at -3 and at 9. So we can see in the graph here, it's closed on both sides, bolded in the middle. And so we have x such that x is between -3 and 9 and including both. So that will be our notation. Remember that this is also always in order from smallest to biggest. So that means that your inequalities are always going to be pointing towards the smaller end, right? Because remember, the alligator or the crocodile eats the bigger number, however you remember it, right? So the bigger number is always to the right. So that means it's always going to be facing towards the right. If you ever get confused or forget, that can be a little trick. Just always remember, eat towards the right. right? And then in this case, it has the equal to because it's a closed interval. This one we're going to graph. We're given the two different notations here. And what we can see from this is that we are not going to include -3, and we are going to include 9. And we can see that really easily here with the parentheses in the bracket. So I'm going to draw the number line. Let's say, kind of eyeballing this. So this is 0. So we've got, say that's -3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that is 9 right there. So now we are going to practice. I'm going to go a little smaller on the marker there. So not including -3, are including 9, and then we just connect those. And if you wanted, I realize I haven't done an example with the brackets and the parentheses. We can do parentheses and bracket, and then connect it that way. It's just your own personal preference which one you want to use. They're both correct. Right, here we have another example. I can see in the graph, we've got a bracket on the left side and it's open on the right side. So I can see here that correlates with these inequalities. So this is telling me that we're starting at -3, ending at 9. It is closed at -3, and open at 9. And moving on, we see here we've got kind of a break in the graph. So instead of the endpoints connecting, they're kind of going off in different directions. You see here and here. So in interval notation, all we really need to do is just take this as two separate intervals. So we've got the interval on the left side here. This is -infinity to -2 right there. So we see this first interval is representing that first part on the left. And then the next interval is 2 to infinity. So we see here this starts at 2 and this goes all the way to infinity. And we use what we call the union symbol to connect them. That's the U that we have there. One thing to take note of is that the intervals should also be in order from left to right or from smallest to biggest. So I'm not going to switch this around and say 2 to infinity union -infinity to -2, because that doesn't go with the flow of the number line and the numbers. But we want to be able to read this really easily and straightforward, so we need to make sure that we have it in order from smallest to biggest, even if being chopped into pieces with the union. We still want to kind of, if we look at the number line, be able to read all the way through. And how do we write this as a set notation? So we still are going to have the curly brackets, and still describing this as X. What is going to happen is we're going to have two different sets of inequalities. So the first set, and we can think of it as this first interval there, I would write that as X is less than -2. Right? So that's the first piece. And the second piece, 2 to infinity, I would write that as X is greater than 2. So the next thing that we want to do is we want to combine the two. So we don't really use the union in set notation. That's for when we're doing interval notation. Instead, what we do is we use the word or. So think about, like, let's say I'm going to go run to the grocery store and I ask you, what do you need me to get? And you're like, Oh, nothing. But you could get me some apples or oranges or chips or some milk. Now all of a sudden a list of nothing has grown into a list of all of these things, right? So we're kind of thinking of it in that way, because remember, a set is a group of things. So we're combining it using or. We're combining all these different groups. So this or that or this or that, and then now it's all together as one. So we'll say x is less than -2, or x is greater than 2. And we close that with a curly bracket. We see the same thing is done here in the next set. However, both of these sets have numbers as their endpoints. This set that we did here just now doesn't have a number as an endpoint, it just goes to infinity. So that's why we see a lot more numbers in this case. And so what I'll do is I'll just break it down into 2 pieces. So this first piece, x is between 2 and 4, including 2 and not including 4. So that's going to be 2 to 4, close bracket on 2, open on 4. And the next one, x is between 7 and 9, not including 7, but including 9. So we're starting from 7, ending at 9, not including 7, we are including 9, and then we union them together. And we see the 2 of those written out here on the graph. A couple more. We have this one here, which we'll try graphing it. There's 2 pieces. We have the first one, which is from 2 to 4. So I'm actually going to make zeros start here. Got 1, 2, 3, 4, 5, 6, 7, 8. Stop that. So we've got the first interval from 2 to 4, including 2, but not including 4. Connect those. Okay, there's the first part. And then we have x is greater than 8, or 8 to infinity, not including 8. And there's the second piece. So now together, that's our graph. Now we have this kind of set notation where we're using not equal to symbol. And basically what that's doing is that's excluding the 1 point out of the infinite number of points that are on the number line, basically just pulling that 1 point out. So in our graph, we can see, it's kind of easier to see when you have the open circle. It's quite literally just an open point, little gap there. And then everything else is still going to be filled in. Everything. It's just that 1 point. It's not even 6.1. 6.1 is still filled in over here. Somewhere in there, right? 6.001 still on here. It's just 6 that's not included. So in our interval notation, we kind of see already here, this is kind of 2 parts. And I'll do it in a different color. We've got this first part here. That can be written as negative infinity to 6, not including negative infinity and not including 6. And then we look at the next part. This is 6 positive infinity. And that's going to be open at 6 because we're not including 6 positive infinity. And then all we have to do is union the 2. And so that brings it together. And the key part here is that the 6 on either end is open. So that means we're excluding 6, but everything else is going to be included in the interval. We have one more that we will do, and that'll be it. Sorry, I went too far there. Okay. So we have 2 sets of set notations They both mean the same thing, but you can kind of see the difference here. When we use the not equal to symbol, we can actually use and to combine the two. Basically what that means is that they're kind of being overlapped, right? So x not equal to -1 means everything but not -1. And then we're saying and everything but not 4. So both of those have to be true, right? Because otherwise, if we were to say or, that would get tricky because x not equal to 4, if I just kind of like ignore this part, right? X not equal to 4 includes -1. And if we cross out x not equal to 4, then x equal to -1 is including 4. So the and is important here because we have to say they both have to be true. So they're both not equal to each other. If we use the different kind of set notation, then we have to break it down even further. It breaks it down into 1, 2, 3 different pieces. So we can exclude -1 with 4. And when we write it in interval notation, we have to essentially do the same thing. Because if we look at the way it's graphed, so we see here, holes, we have these parts. We're going to have to break it down into as many parts as we see here. So we see that the first part is from -infinity and then to -1. That's one part here. So we're going to go -infinity to -1, not including -1. And then the next part, we have -1 to 4, not including either of those. I'm just going to go ahead and do the union there. And then lastly, we have the last piece, which is from 4 to infinity. We'll union that, 4 to infinity, and then that concludes our interval notation. So with interval notation, no matter what, we always have to break it down into the different sections that you see kind of on the graph. So it's when I use a lot of interval notation, and that's because I like to see the graph, I like to see the breakdown, kind of like what you see here, the different colors. And so that's why interval notation is helpful in a way because it helps kind of visualize the breakdown of the number line. Whereas with set notation, we can kind of condense things a little bit more, which is also helpful at times to be able to condense things and not have to write and expand as much as we need to. So that's why we have all the different kinds of notation, because sometimes one way will suit your purposes better than another, and that way you can always be able to go back and forth between all the different kinds of notations. All right. That concludes this video. I hope it helps, and have a great day.